pre-algebra students, Mr. Lawrence here with a flipped lesson for you. And today at the end of it, you will be able to say, I can calculate the area and perimeter of squares, rectangles, parallelograms, rhombi, and triangles. And some of this should be really easy. It should all be reviewed from last year, but we need to cover it. All right, first of all, let's do the perimeter of this parallelogram right here just to begin with, just for a little warm-up. And remember, if you ask Private Alan Strauss, PFC Alan Strauss, he will know that perimeter is the distance around the polygon, right? So he's got to figure out how far he walked. And if he starts here at this corner, he walked 13 meters plus 30 meters plus another 13 and then plus another 30. And if you add that all up, I believe you're going to get 60, 26, 86 meters. That is your perimeter. Okay, so to go ahead and do area now. Now, by the way, I know some of you have a different way. You're going to say, hey, Mr. Lawrence, I want to do 13 plus 30 and then multiply it by 2. And that's perfectly fine. You're going to get 86. I don't mind different ways. I'm just explaining what perimeter is and one way to find it. Okay, now we're going to try to find the area, but if you were paying attention Friday to the intelligent Logan Stasiak, you will know that we can't find the area of this, right? Logan, tell him why. Oh, you guys aren't even listening to Logan. Logan knows that you need the height. And let me see, I think I have a height hiding right. Ooh, where'd it go? Where'd that height go? Right here. Okay. That looks like my height. How do I know that's my height? Because I have a right angle. Let me show my right angle. There it is. Okay. Now I need to know how long that is. And I'm just going to tell you in this case, it's going to be 12 meters. Okay. I know that Ariana said something very intelligent. Maybe we can use the Pythagorean theorem to figure out like the missing part. And that's true. In this case, we don't have enough information to do that. And I love that she's thinking about that. I just think it's so smart. But in this one, we're not going to be able to do that because we don't have quite enough information. So we're going to do, for area, remember I always like to use the formula. Area equals the base times the height. Okay, so in this case, I'm going to call my base 30 meters. And then my height is going to be 12 meters. Notice I'm not using the 13 in this problem because there's no right angle involved. All right, and 3 times 12 is 36, so 30 times 12 is 360. Meters times meters is meters squared. There you go, 360 meters squared. Now, by the way, if you're wondering why this this formula base times height works for all these different shapes, well, did you ever stop to think that this parallelogram might, just might be a rectangle in disguise? For example, if I cut off this triangle here, and let's see, he was here, right? And then I bring the cutoff piece over here. Look at that. What did I make? I made a rectangle, didn't I? With a base of 30 and a height of 12. Okay, so let's come on down here. Now, by the way, we're going to do triangles, and we're going to have to adjust our formula, like Miss Eubank will say in class today. Then our formula for the area of a triangle is just like the area of a rectangle or a parallelogram. We're going to do base times height, but one thing we don't want to forget to do is cut it in half, divide it by 2. Why do you suppose that is? Well, watch what will happen if I, let's see if I can do this. Oh, that's not even a, hold on one. Okay, now I'm ready to demonstrate. If I take this triangle here and I clone him, and then, oops, I didn't want to do that. Hold on one second. And I flip him. See, where's my flip? Up and down. And then I can position him. What do I get? I get a quadrilateral, don't I? With a right triangle, well, this is a right triangle, sorry. With some triangles, it actually looks perfectly like a square or a rectangle. That's why this works. All right, let me get this guy out of my way. And now I need to do the perimeter. And the perimeter, again, is the distance around the shape, except, danger, Will Robinson, we only know two of the sides. We're going to have to use the Pythagorean theorem to figure out the third side. So I'm going to use a squared plus b squared equal to c squared. And I'm going to find my right angle, draw to the hypotenuse, and I know that side is my hypotenuse. The side across from the right angle is always hypotenuse. Okay, so I'm going to fill x into c's position, and then a and b don't matter. Okay, so 5 squared is 25, 12 squared is 144, x squared, I'm going to add, get 169, x squared, and then of course to undo the square, I will take the square root of both sides. So x is going to equal 13. All right, now that I know x is 13, my perimeter is 12 plus 13 plus 5, which ends up being 30 inches. And there we are. Okay, to do my area, all I need are the base and height. So I look for my right angle, and it looks like I have a right angle here. One side will be my base, the other one will be my height. So the area is going to be 12 inches times 5 inches. Okay, and then I got to remember that I'm going to divide my answer by 2. All right, so 12 times 5 is 60. 60 divided by 2 is 30 inches squared. Now, some of you might be thinking, hey, we got the same answer. No, we did not. 30 inches is measurement in a straight line. Okay. Okay, and the inches squared is the measurement inside the shape. Like if I take my highlighter, the 30 inches squared, I just found out how much space is in here. See this blue area I'm shading in? Like, for example, the amount of paper it takes to make the sheet of paper is a measurement of area, the space inside. If I have a picture frame, the frame is like the perimeter, but the size of the picture is the area, if it's an 8 by 10 or something like that. Okay, so let's move on to this next triangle. Let me get off highlighter mode. All right, and I'm going to do perimeter. And perimeter, I have an isosceles triangle here, and it looks like those two sides are both 26. So my perimeter is going to be 26 plus 26 plus 10, which ends up being 62 inches. And so there's my perimeter. Now to do the area of this one, I need to know the height. And look, I happen to have a handy dandy height measurement there. And I'm going to put my right angle in. Now, remember Ariana was talking about trying to use the Pythagorean theorem. I can't use it right now as is because, but if you notice the base down here is 10 inches, right? And that height is cutting it directly in half. We can say that this piece here is 5 inches. And now that that's 5 inches, we can say the Pythagorean theorem will work. We can use the Pythagorean theorem because if you watch right here, whoa, not sure what that is. Having a hard time drawing my right triangle. Sorry about that. Ugh, that looks ridiculous. Let me get rid of that. Let me try this again here. It's because I'm on the airliner having a little trouble with this, ladies and gentlemen. Sorry about that. Okay, you see the right triangle here that I'm highlighting? So all we need to know is the height of that right triangle. And once we do that, we can go ahead and then use the Pythagorean theorem to find the height. And so if I find my right angle, I'll draw a line, an arrow to the other side, indicating that this side is C. So when I do a squared plus b squared equals c squared, I'm going to put 26 squared in. Okay. I'm going to do a squared plus 5 squared. So I'm going to square and get a squared plus 25 equals 676. I'm going to subtract 25 from each side. Okay, and I'm going to go a squared equals 651. And of course, I need to take the square root of both sides, right? And then a is going to equal, I think it comes out to be 25.5, but I'm going to bring up Google. Hold on. Okay, if you see, I brought up a calculator in Google just by doing 26 times 26, and then I subtracted 25. And I just hit the square root of, what do I need, 651? And I hit equals, and I get 25 and 5/10. I knew that because I'd done this problem earlier. But anyway, so let me get back to my lesson here and get my smartboard or my airliner up and functioning. And okay, so it looks like we're functioning, so it's going to be 25 and 5/10. 25 and 5/10. Okay. And so now I can do my area because I have a right angle, I have the base, and I now have the height. So I'm going to do the area is going to be equal to 25 and 5/10 times 5, and then I've got to remember to divide by 2. Okay, and if I want, I can go back to that calculator I was using, and I can do, I'm going to use 25, and I don't see a decimal point. I don't see the decimal point. Oh, there it is right in front of me. Sorry. Okay, and we're going to multiply that by 5, and it's going to get us 127.5, and I'm going to divide it by 2, and then we're going to get 63 and 3/4. And I'm not going to round that. I'm going to leave it as that answer. And am I in, whoa, crazy mode here? So A is going to equal 63 and 3/4. And we are inches squared because it's area. I wonder where the square inches came from. I did inches times inches, right? When I divided, I didn't get divide by any inches, so it stayed squared. Okay, now we're going to do this triangle. We've got the perimeter first, and of course it's going to be 18 plus 20 plus 30 inches. Excuse me, which ends up being, was that 50, 68 inches, and we'll leave it like that. Okay, now, again, we can't do the area because we don't know the height. I'm going to get rid of this 18, by the way. It's kind of in my way. To get the height of this, we could actually do this. We could use two pieces that are not actually a part of the triangle. Okay, now we still know our base is 20 in this case, right? Here's our base. We need to know this distance here. Okay, now we're not actually using the Pythagorean theorem because we'd have to know the length of that piece before we could figure it out. But the height is actually, if we were on top of this triangle, we want to know how tall it was, we could drop a tape measure down. I'll tell you what, let's just for the sake of easy numbers, let's say it's 8 inches. Okay, so the area of this triangle, we're going to use that old formula, base times height, right? And then we're going to cut it in half. We're going to divide it by 2. And again, that's because a triangle is half a rectangle or half a square or half a quadrilateral. It works for all those formulas. I hate to have like 800 different formulas. I use base times height for all the shapes we're talking about. Okay, so the base is going to be 20. The height is 8. And we're going to cut it in half. And I believe that we are going to come up with 80 inches squared. And there you go. And that's a little bit of homework help for you. So Mr. Lawrence going to sign off now. Good night, everybody.